I'm in fourth year right now in Manipal University, Jaipur, like one of you only. And I've recently joined STC like about 2, 3 months back, and I've been interning as in the DevOps position. And today we'll be taking your lectures on introduction to Linux, Unix, whatever we have. And then that's the first session that Arnav will be taking. And then the second session would be Git and GitHub that I'll be taking, which is from 2 to 3. If you have any doubts like throughout, you can just open your mic or write in the chat. We are very happy to answer it right and then.
Okay, yeah, so we'll try to keep this session interactive, and we'll try to make it as crisp, as short as possible. We know everybody here is either working or enjoying the summer vacation. So let's make the most of the limited time that we have. So let's start with the basics. What is Linux? So first of all, everybody who here has heard of Linux, just raise your hands in the meet ones. Assume you're all in the second year at MUJ. There's almost little to no chance, and if you have not, so yeah, great to see. Okay, so if anybody is up to it, can anybody explain to the to everybody what Linux is? Just freestyle it. Just try go off the top of your head. Um,
Guys, all of you participants, please participate with your full enthusiasm. If the presenter is asking, it totally depends upon your enthusiastic. So the presenter can
okay, so
present you
can
everything.
can anybody write in the chat your understanding of Linux? Open source scripting language. Okay, that's right, Riddhi. Riddhi is correct. It is indeed open source. That is one of the hallmarks of Linux, actually, as we'll come to see. Just give me a second. I'll just get my get my um yeah. So Linux is indeed an open source operating system. Yes, Samar is correct. It is a type of operating system. Robust tools really does not tell us much about Linux in this case. So how we want to think of it is that Linux is okay. Ayush says manages hardware and software resources. So that is effectively what a operating system does. We are specifically talking about Linux. So Linux is, you can consider it a family of operating systems. Okay. So there are like any family. So even for example, you are using Windows. I am assuming like 99% of everybody in this call would have Windows, like 1% Mac users, 0.05% Linux users, people like Karan, who are a little, on the edges of society. So, but so Linux is generally not considered a consumer operating system, but it is a family of operating systems. So the Windows family of operating systems, the one you are using right now. So you are using Windows 11, which is the latest iteration in the Windows family. Before this, we had Windows 10. Sometimes there are multiple parallel versions. Windows Server is a separate operating system in the Windows family for servers. So that's a family. Then there's Mac OS. That is also a family. It has versions. It has different distributions for different purposes. Uh, your phone runs Android or iOS. Those are also operating system, and they can also be said to be operating system families since they have multiple versions. So now coming to why, like what Linux specifically and why it's an important operating system. In fact, I would argue that it is the most important operating system in the modern world. Like you have your computers, your computer runs Windows, but most computers do not run Windows. Most computers definitely do not run Mac OS. Most of the so you realize that your Wi-Fi router, that has an operating system. Most of your TVs have an operating system now. A monitor would have an operating system. A printer also, the new ones tend to have operating systems. Most of these rely on, if not the Linux family, but on a related family of open source operating systems, which obviously contain the kernel and everything. So let's get into the history of Linux. Linux was founded by this man called, I'll just share my screen. Give me a second. Yes, my screen should be visible. So the man you see on your screen right now, that is Linus Torvalds, among the most important computer programmers in the world. Uh, he uh, he is the original creator of the Linux family of operating systems. He created it because he wanted to basically there was an existing operating system called Unix, and Linus wanted to uh, you know uh, make one. Unix is not it wasn't free as in freedom in the way that we tend to think of it today in terms of open source software. So Linus wanted to create something like that, but for an operating system. Now, at the time, this did not exist as a paradigm. The open source you think of today draws heavily from the work of people like Linus Torvalds and their other uh, other contemporaries like Richard Stallman, Ken Thompson, Dennis Ritchie, and others. Linux was originally based primarily on the Intel 386 chipset, which you will actually like if you ever go into the Linux code today. It's on GitHub, I believe, or on its own version control. You'll find some, not exactly Easter eggs, but the legacy of the original chipset that the operating system was based on till today. Linux is the most so coming to why Linux and why like us computer science students and developers in today's world, we must know Linux. It's an operating system made in the 90s. What's the relevance today? Well, as we discussed, it's already practically the most used operating system in the world by the fact that it's on a sheer excess number of devices, especially ones that users tend to think that just work out of the box, but you have to have them working. There has to be people like us, engineers, working on the back end to make them work. It's qualitatively different from a consumer operating system in most places it is used, but it can also serve as a consumer operating system. Like I can pull up Ubuntu on my computer right now. That's a Linux distro. It's just as good as Windows, I would argue better. And there are a lot of distributions like flavors in which you can get your Linux distributions. Android, your phones, the most common phone operating system is basically based on Linux. As is, there's an extensive layering on top of it to make it work on mobile and all so on. Linux, like it's very hard to overstate the importance of Linux. Have you heard of the world's fastest supercomputers list? This is top 500. Every single system on each of these computers would be running Linux. It's just the it's just the standard for computing in the present day and age. There's no other way to get get a high performance computing setup in today's day and age. Any company, unless they are dealing with some very specific use case, say where they need a Microsoft server, or say they're dealing directly with systems based on Apple or Microsoft proprietary systems. Like if you are developing, say, an app for Mac OS or iOS, then sure you need a Mac OS server or whatever. But to build your app or whatever. But for the vast majority of cases, Linux is the server you will be using. Cars run Linux. The International Space Station and the Tiangong Space Station, the two human space settlements today, also exclusively run Linux. Basically, every every major human enterprise that matters in a way that you need it to be reliable and you need it to just work will be based on Linux in some way or the other. Okay, now I'll stop sharing my screen and let's come to the so as we have established, let's discuss why do most servers actually run Linux. So first of all, Linux is completely open source. There is no part of the Linux source code that you cannot view, edit, access, whatever you want to do it. And it's free as in freedom. There's no limitation placed by the licensing of Linux on what you can do. This you can even think of it. We have the system called copyright, right, which preserves the maker's right to their whatever their intellectual properties. Systems like Linux, while they technically come under copyright, they can be considered to be the opposite of copyright, which is copy left. That's literally the word. It's copy left, and it's yours to do it as you wish. If you want to do this the same to Windows, for example, Microsoft has an army of lawyers who will stop you before you can say Windows 12 or anything. Like there is no clear way to modify it. They own their source code. The source code is not public. They keep it under locks, under wraps. It's like the recipe to the Coca-Cola drink or how they make a KFC sandwich. Now it is how it's come to this stage where Linux is the most used in the world is how it's a feedback loop of how all these things develop. So at to begin, okay, okay, yeah. So we'll just conclude the Linux discussion quickly. But how this came about is that Windows costs money to begin with. Developers, not all developers have money, so developers were learning Linux to begin with. And once they went into the industry, they obviously started using what they were already comfortable with. So that is how they ended up at how everybody in the world ends up at Linux, and now we carry on the legacy like as developers that we do not Linux is the way we are going. There's no other way to play it. So let's discuss Linux commands. I'll share my screen into one of my servers. Okay, my screen should be visible. So
little bit font can be
yeah, sure. I think this might can be much bigger. This should be good enough.
Yeah, it seems so.
Okay, so yeah, so this is my server. It's as you can see, it's called Mir. The operating system on it, as you'll notice here, is called Ubuntu. Okay, so now Linux, all operating systems have shell. Linux comes with various shells by default. Right now, we are using something called Bash. So let's go through some of the basic Linux commands. I'm sure a lot of you would already be familiar with it. But for example, ls, this just tells me what's in my directory right now. So these are all the files I have in my current directory. cd, which is change directory. So say I want to go into, let's take the Minecraft directory. That's I had a Minecraft server running on this system at one point. So we go into CD's full form is change directory. CD Minecraft just puts me from my current directory, which was slash, into Minecraft. So I'm now in slash Minecraft. Now I run ls inside Minecraft. It shows me the files inside. Now say how do you want to know what your current directory is. So for that you write pwd, that is print working directory. That's the full form. So pwd tells you you are in slash home slash ubuntu slash Minecraft. So say I'm outside and I go to some different directory, and now I need to get to the original Minecraft directory. So I can copy that and I can cd back into that. So I can get back to that from there. Yeah, this is an example of using an path navigation using change directory in Linux. Now let's say you want to see a complex directory and how the files are in it. So there's another command called tree. So okay, tree should not have been run on this directory because this directory contains way too many files, as you can see. But as an overall, you can see in the scrolling, all the files have been now listed as in a literal tree, as in inside the tree L-1 would be actually better. But I think this demonstrates the purpose, like as a tree. So this is the root folder. There's another folder inside it. There's another folder inside it. The files inside that folder. The next folder. So tree is useful for visualizing the directory structures. Now let's. The question is, how do you create a directory? So that command so all the Linux commands are designed to be sort of like a simple grammar that you will remember after hardly a couple days of using Linux in a general manner. So how do you want to change a directory? That's just called make directory. So to make it short and easy to type, we call it mkdir. So mkdir sdc test. So that makes a directory called sdc test. I'm typing out the full name so easy, but also on Linux, most shells, you can just, so if you know what you're typing, you can just say, start typing SD and tab. And if it's unique enough, it will just fill in the rest for you. It's intelligent like that. It can fill in it can make your work easy. Now we made a directory. Now say we want to create a file. The command for that is touch. So say I want to create a file, touch test.txt. So now let's see what this is the test.txt file. It's now created. As you can see, if I run ls, you can see a test.txt file. Now I want to write something inside this file. Right. So first, let's see what's inside this file. To see read that, we use a command called cat, literally cat. So cat test.txt. This will give me what's inside the file. As you can see, it did not print anything right now since it's understandably blank. Now let's get into the file and write something. So to get into the file, we'll use a text editor. So you have Microsoft Word, you have Notepad. Here we are on the command line, so we'll use one of the command line text editors. The simplest one that you want to use right now is called nano. So you just write nano test.txt. This opens a text editor. As you can see, it's GNU Nano. GNU is the thing under the sort of organization which develops Nano. There's a few helpful commands here. So say I want to write, this is the SDC DevOps demo. I wrote this. Now I want to save it. So I can just hit Control X. Control X puts me to save modified buffer. Save modified buffer just means, are you sure you want to save what you have just written? I just enter the key Y, and that enters. It asks me the file name. I want to keep the file name as I created it. So it just test.txt, and I enter, and it's done. Now, if I run cat test.txt, I will have the contents of test.txt dubbed out to me. So I can see it directly from there. Okay, now let's discuss how to copy and move a file. So let's create another directory inside this, which is SDC test2. Now you are asking, you want the SDC test directory, the test.txt file inside SDC test2. So it's right now here. In tree, you can see it. SDC test2 is a separate directory. We want test.txt to be under this directory now instead of just under SDC-test. How we do that is we use the command copy. Copy can be abbreviated simply to CP. So CP test.txt, SDC test. So this command takes two arguments here. Usually we are giving one argument. Like cat has, as you can see, the cat command has one argument, that is cat test.txt. So test.txt was the argument we were passing to cat. This is the file that we want the cat command to look at. CP takes two arguments. So the first is the file you want to copy. So that's this. And second is the path where you want to copy it. So that's this. And if we enter it, it's done. It does not show a success or anything, but as you can see, we can go inside SDC test2 and check, and test.txt has been copied here. So now it exists in both the directories. If I run tree, you can see there's a test.txt outside, there's a test.txt inside. Now say I want to delete test.txt, I don't have any use for it anymore. Command for that is remove rm. So I run rm test.txt. It's that simple, much easier than going into a right click context menu, delete, then it asks if we wanted to go to the recycle bin or what, just rm, and that's done. So it's gone from here. Now you'll find it's only inside SDC test2, where we copied it. Say now you want to move it back to the parent directory, that's SDC test. You just run mv SDC test. Mv, again, this takes two arguments. So first, as you'll recall, the file we want to move, mv is move. So what's this test.txt? That's the first argument. And second, where you want to move it. So that is SDC. That is this directory. So might be useful here to discuss this dot dot operator. This dot dot operator refers to up one level in in Linux in this particular shell. So if I do this, it will send it upwards. So it will now not be here, but if I go up, again, as you can see, I use cd dot dot to go up one directory. So if I go up one directory, now you can see it's here. So we have covered pwd, ls, cd, tree, mkdir, touch, cp, mv, rm, and cat. Now let's say you have a, let's discuss the structure of the Linux directories. So let's come back to home. If you just run cd change directory and blank with no argument, it will always take you to your home directory, which you can think of in like in Windows, you can think of it like there's also home directory in Windows. That's the one where you have your documents, your downloads, all those folders. So that's the equivalent of this for Linux. Now let's discuss the Linux directory structure by going up another level above from home. Okay, so this is a hierarchical tree. I'm now at home. Now I have two options: OBC, Ubuntu. That's just the operating system. So even on Windows, you will find something similar. We go another directory up. This exposes a bit of the Linux directory structure to us. Okay, so let's go through it systematically. As you can see here, there's something called root. Root can be said to be the wait, sorry, my bad. Root can be referred to as this particular directory as well. This root is a different aspect of that, but this contains everything our system needs to run. There's a folder called bin. Bin stands for binaries. It contains the essential files. So for example, the commands we ran just now, ls, cp, mv, rm, all those commands, they have to be defined somewhere. Any program, even an operating system that's just a program, needs those commands defined. So bin is where you will find those defined. Boot right here has the essential files that the system needs to boot. So the kernel, the bootloader, other configurations. You can think of it like, so if I got rid of boot and I try to reboot this system, it will not be able to boot, since this is the first thing it looks for when it tries to boot. Those are the scripts it uses for that. There's a folder called dev. Dev would be containing device files. So you can think of it like if you wanted to mount, say, a hard disk to your Linux system, you would find it, you would mount it inside dev/sd1, sort of like how you in Windows Explorer, you usually have hard disks appearing in the devices and drive section. If you open your Windows Explorer right now with Windows E, you will find an identical structure to as you will find on in dev, inside there. Then there's some, what else? etc. etc contains things like systemd and others that we will not get into right now, but think of it like a configuration files that apply system wide. So if you want to, say, run something as a service, say you want an application to start up every time you start up your Linux server, so etc is where you would tend to put that. Home is where we came from. As you can see, if we go back into home and Ubuntu, it will send us back to where we were. Ignore this. You'll see an OPC here. You can ignore this. This is a function of the specific cloud provider I'm on. This is a Oracle cloud server. That's why that OPC thing exists there. But that's you will usually only have Ubuntu there. Okay, we'll take some feedback after we finish this section. There's MNT where you can mount other temporary file systems. OPT, there's OPT right here where we install third-party software packages. So things like Snap or package managers will go into OPT. There's TMP is self-explanatory, temporary. SBIN is system binary. You will usually not be messing with any of these. Most of these are generated by the system itself, so there's no reason to go. Slash user as system user related programs, libraries, etc. Var has variable data files like logs, databases, other files that change relatively frequently. Okay, so does anybody have any questions till now? Just seeing. Am I going at a comfortable pace for everybody? Do you want me to slow down? Do you want me to speed up? What's the verdict on that? You can just write in the chat if you don't want to unmute, or you can just unmute and go ahead. Okay, seeing none, let's assume I'm going at a comfortable pace. So now let's discuss packages. Packages is how you install applications in Linux. If like packages is just you can think of it as a term for applications. So Linux uses a package manager called apt. If I run just apt, you get a command line package manager, provides command for searching, managing, etc. Okay, so let's see how we install a package. Let's take an example package, say Apache 2. Apache 2 is a web server. So I'll just, oh yeah, another thing you need to discuss is elevation. Elevation, by elevation, I mean permissions in this case. So everybody runs as a user. So like right now, my username is Ubuntu. That's the who I'm running as on the system. However, if I say Ubuntu is my main personal account user on this operating system. If I want more permission, say I want to modify a system file or something that is forbidden to me, so I can go sudo su. Sudo stands for super user do, and su is just super user again. So sudo su elevates me. So now my user has changed, as you can see, to root. The system remains the same. The system is called mir, the Russian word for progress. But I was Ubuntu before, and now I'm root. And with root, I can do a lot more. With root, with root there are no limits on my user. I can go and delete the boot files. I can go and delete. I can delete everything. I can create anything anywhere. There are no permission issues that's whatsoever stopping me. To exit root, I'll just type exit and come back to my normal user. So package manager. So let's try if I want to install it directly through apt. So I write apt install Apache 2. So as you can see, I just got a could not open something something, permission denied, unable to acquire something something. Are you root? It's straight up asking me, are you root? I am not, in fact. But if I want to run, so I need to run that command as root. That's the only way I can run that command. So to run that, I'll just go sudo apt install Apache 2. So all I did was I prepended sudo to this command, and now it will work. So as you can see, it read the package list, which is the repository it's getting there. It built a tree. It read the state information. It has gotten all the packages I need. So it's all the important packages right here. Let me just close some of my notifications. Yeah. So it's also telling me how big of a file it's going to install. So it's 1769 KB, 1.7 MB, not a. So after this operation, 12.5. That's what it will be fetching. After this operation, 12.5 MB will actually be used on my system. That's like after it gets a compressed file, it unpacks it on my system and installs it. So if I continue, you want to continue, why? So do note that this will not work immediately because Apache 2 runs on my system on a port, the port 80, which I am currently already using since this is a production system for myself. So that it will not be able to run in the browser directly right now, but it will install. It will install just fine. So as you can see, that's the installation process happening. It looks like a lot of stuff's happening. A lot of stuff is happening, but you do not actually need to care. It just completes that. You type that, you wait for 5-10 seconds, and it's done. So it's done that. It restarted what needs to be restarted, and Apache 2 is now installed. To run that, I'll need to go to another. I'll need to go to another system. So I'll just stop sharing my screen and go to switch to a fresh system. First, I'll show you how to uninstall it. So sudo apt remove install remove. So Apache 2. I'll just get rid of it from the system. It asks me. It will not free all of the space on the system, but it will get rid of the main package that I want not to get rid of. I just continue with Y. If I do not want, I would write N and enter that. Okay, that's uninstalled. I'll just switch to a new system and start screen sharing again. Okay, while we wait for the new system to come online, I just booted it. It's coming in a second. So to ask, yeah, does anybody have any doubts or questions they would like to ask? I think I muted myself accidentally.
Yes. So anybody, students, can unmute your mic and then put your questions, or otherwise type in the chat box. You are free to ask any questions.
Okay, great to see it's all clear. Um,
So it seems that it is going good. And now you can continue.
yes, I just waiting for the machine to spin up. Yeah, I think the machine must be switching to Linux early on in your career. Sure, but like if obviously if you so it's like how you ride a how you learn to ride a bicycle, you will grasp the go quicker. Obviously, if you are they say that you can't really learn until you just go and fall down a couple of times while running a cycle, and then you learn to keep your balance. It can be similar. There's no such reason like you will sometimes just need another operating system for consumer computing things like so Adobe software that doesn't really run on Linux right now, or games or anything else you might use your computer for. But it's definitely useful to have it as a there's this concept called dual booting where you can just have this thing on your uh, on your two operating systems on your machine. So you have both Windows and Ubuntu installation. Okay, so something like that could be really useful in your career. So like you will learn to daily drive both and try to use Linux is just better as a developer. You will thank your like it will be just better for you. It will make your life easier. Windows is a necessary thing we use since computers come installed with it, but there's no reason to stick to it forever. There's a wealth of different sorts of operating systems out there. Linux flavors are come by the dozens. There are whole online there people have been arguing since the 90s on which Linux distribution is the best. And all of those are really excellent developers and excellent computer scientists, engineers, all that. So it's good to be in that company. So it's definitely good to have a Linux installation on a system. There's no reason to switch to it, but it's good for you only to have it. Okay, we are on a new system. This system is called Castle Romeo. As you can see, my user is currently Ubuntu. Let's get into the. Okay, first of all, let's see if you want to see what's running on your system. So on Windows, you have something called the Task Manager, right? If you hit Control Shift Escape on your system right now, you will get a Task Manager. How do you get something similar on Linux, you ask? So the answer to that is something called Top. So Top opens this window, which shows you. Okay, it's a similar view to the Task Manager. We can go through things here. So it's PID is process ID. This is important. We'll come to this later. There's user. What user displays key a process. What user is it running as? Process ID identifies the process uniquely in the file in the computer. User tells you what. So most of these are running as root. This tells you something important that these are installed as root and they are system files. As you can see, the top process is just here. That is running as Ubuntu because when I was like I just ran it right and I was the user Ubuntu, so it's right there. Yep, you can see the CPU percentage it's consuming, the memory percentage things are consuming. If you can see on my system, so there's things like tailscale, which is a VPN running. The top command itself consumes some memory because it's fetching every other processes things right now. Other than that, the system is fairly lightweight. There's not a lot running on it. As you can see up top, pun intended, top left, and there's tasks 141 total, one running for 140 sleeping, which means they're not really actually actively consuming much memory. That just they will wake up and do their task whenever it's needed. Um, Two users, that just refers to root and Ubuntu. You can have as many as you want on a system for for it to make more sense. Load average is important. It tells you how much how much load there is on your system. So right now you can see it's 0.12, 0.26, 0.14. That's about O. If it's greater than 1, that is a O. Usually it refers to the number of cores you have. So if so this system has 1 core. So anything above 1 means the system is fairly overloaded. Below that, it's fine. Okay, that is about what we need to discuss. We can to exit any command. So if you open top and it opens like this, and now you can interact with it. But if you want to exit any of these, you just hit Control and C in your terminal, and it will get you back to where you were. If your terminal might get dirty, so you just hit clear and it cleans out the entire thing. So now you can start with a fresh workspace. Uh, the terminal is important, that it is something you should embrace if you are using Linux. There are a lot of ways to get really faster in your workflow. So the point of computer should not be to become the whole job. The point of a computer and operating system, a lot of the things we do as engineers is that they should get out of the way to let people accomplish other functions. The terminal should be thought of as a similar tool. It's supposed to get out of your way to let you get your job done quicker, what you are working on. So say there's a bunch of commands. So a good thing about some terminals is they store all of them in the history. So if I ran a very complicated long command and I need to run that again, I can just start clicking the up arrow key and go back up and see the commands that I was running in the history. And this will it's stored for a while, so I can. So if I want to remove Apache 2, I found it from just the history and I ran enter, and it will delete it. It will ask me for confirmation now. It might already. It's asking me. I do yes. Okay, so that's we stop. Okay, we are a little short on time, so let's get to the network commands. There's the let's just should not run this, but let's let this complete. There's three commands we'll discuss with network commands. That's ping, PING, as in ping pong. That's actually where it comes from. Then there's curl, and there's wget. Okay, so ping can be just thought of as hitting I just interrupted operation using Control C as we discussed, and I'll clear it. So say we want to check if the web server is reachable. So we just run ping. Now here we can enter the IP address of what we want to reach, or we can hit a domain name. It will resolve that using DNS. So if I hit ping google.com, so it's pinging google.com. As you can see, it resolved it to an IP address, and with some data, it's pinging. We are getting the pongs back. So I have a latency of 18 milliseconds to google.com. So that's ping. Now, once I control C control C to end. That's very important. I have the statistics: 13 packet transmitted, 13 received, 0% packet loss. If I ping something that wasn't a real domain, say ping check.sdcmuj.com. SDCMujCSE is SDC's official domain. So as you can see, it does not find it. It does not exist on the internet. If you open it, it will not open anything. So it obviously cannot also find it. Okay, ping works the same for IP addresses. Now let's see curl. So I'll demonstrate curl using one file. This is from the original maker of Linux himself. That's Linus Torvalds. So first, let's curl this file. Okay, so curl just prints out. So this is a raw. This is from GitHub. As you can see, it's the author's name is Torvalds. That is Linus Torvalds himself. The repository is called Wo. And so we got the print of this. So curl just prints out in your terminal what you are fetching directly. So as you can see, this is the exact. If you open this link right now, if I control click, I think my screen for my browser is not shared, but it is also what we'll open. I'll put it on the chat so you guys can verify. It is the identical. I will I'll address some the doubt Anudit has raised in the chat in just a second. Okay, so yeah, so that's curl. Now say you want to, so this is the file, you can click on it and see in your browser, it will load the exact same thing. Now, what if I want to download this file on my system? So for that, I use something called wget. So if I use wget, I'm pasting using Control V in my system. So that's where that came from. And I get wget, and now it says readme has been saved. So if I run ls to list directory, I will find something called readme. And if I do cat readme, I will get the output again. So wget saved that thing in my directory, curl printed that to my terminal. Okay, so now wget is basically focused on downloading, while curl is focused on fetching directly. Now Anuridha is asking what is the difference between bash and terminal. So terminal is a type of operating system. The terminal. So okay, do you guys remember what you guys might remember from computer class, there's something called the GUI. That's the graphical user interface. So like Windows right now, what I have here, it's called the graphical user interface, right? So I have a mouse, I have a keyboard, I click and point at things. Before GUIs, there used to be something called CLIs. CLI is command line interface. What we are using right now, this is technically called the command line interface. The modern day terminals refer to terminal emulators, which look and feel like how they used to, but they work quite differently. Okay, so bash, what I refer to is the terminal type I'm currently running here. We use terminal, shell, command line, everything interchangeably to refer to the same thing. That is the thing you see on your screen right now. This thing is referred to by all three names. Bash can be said to both be it's a type of shell, and it's a scripting language. Somebody mentioned scripting language at the start of this meeting. So bash, you can also write bash scripts to automate things. I might have some here on this system right now. If I will see the pull.sh, you see this is a shell script. It's not bash exactly, but it's very close to it. But yeah, bash is a script shell, and it's also the shell. It's the most common one here. There you have a CLI on your Windows system as well. If you open the command line CMD or PowerShell, those are both CLIs for Windows. They work somewhat similarly. They might have some different commands, but you can just, if you open your command line and ls right now, ls will also work there. They both follow the same basic structural grammar. Okay, so yeah, there's about that for that doubt. Okay, so I think that is it for Linux. So we'll just get to the rest of the stuff, but I think we have cleared everything up as to basic Linux. If anybody has any questions they would like me to address, now's the time before we move on to DevOps. Now you can put your questions in the chat. Okay, so now we'll focus. Let's get to DevOps. So DevOps is the team me and Karan represent here from the SDC. Now DevOps, basically, if you just look up the definition, it will refer to something called something like out the automation of software development, IT, etc., etc. I will define it as simply as I can. So developers develop for like as a developer, a software developer, they are developing software for consumers. Like so, if you are say you're on Microsoft Teams right now, so a person working at Microsoft working on the Teams project is developing software for you. I would sort of say that DevOps are the people who are developing for other developers in a manner. So our job is to make the work of developers easy because the developers have a lot of things to juggle with. We are the technicians of sort, the engineers who make their performance. We abstract away the layers that they should not have to deal with, and deal with it on our own so that they can focus on the sole software development part. So, for example, deployment. Say you want to put up a website up. So a developer will be overburdened by having to make both the website and also deploying it to the World Wide Web. Not to say that the developer should not know how to, but in a large organization or any sort of professional workplace, it's good to have a division of labor. So DevOps handles the deployment, integration, monitoring, all that part of the uh, labor division in this manner. So there's 3-4 terms like continuous integration, continuous monitoring, continuous deployment, which can be said to be to encompass DevOps. Okay, so let's look into how SDC's current workflow works. So I'll first of all, like I'll show you the sort of thing that's possible with the a basic knowledge of DevOps. I'll just switch my screen share. So this is just a preview. It's nothing. This is the sort of thing I did after learning DevOps on my own. So this is my server, the one we are looking at here. There's a few errors. Ignore those. I don't have time with my internship at all to solve them. But this is my server's homepage. The location is set to Jaipur because I was in Jaipur during college. I don't bother to change it. These are the things I'm running. For example, I'm running something called Pi-hole. This is running on a Raspberry Pi attached to my Wi-Fi router, and it blocks ads on my system. I have a bookmark manager. I have a reverse proxy. I have some media managers, um, all that sort of thing. And this thing is running on the mid server that I just showed you guys earlier. So this is the sort of things that I did not write any of the software that you saw running, but what I did was I took existing software from GitHub and other places, I modified it and I deployed it for my purposes. And that is what I do like as an intern right now. So I'm I'm also deploying software that other people wrote, the developers at the company. They write it, and I ensure that it gets to our client in a deployed and proper manner. Okay, so let's discuss the areas of intent that a DevOps person needs to know. Okay, so primary among those is things like networking. So say if you're handling DevOps for a web app, you need to know how to how to put a website up on the World Wide Web. In fact, some of the assignments we will be giving you guys as prelude to your interviews will might involve something related. You should know how to put up a website on the World Wide Web. Like if you ask, if say Jeff Anker sir asked me right now, he has this web app he wrote in Next.js, whatever, just a simple app, and he wants it accessible to somebody, I can have it up and running in the next 5 minutes. That's the job of DevOps. If a normal developer went to do that, they could obviously do it, but our work is to do that simply, fast. We can even automate it. To put a website up right now with the current SDC system, it will take me like 3 steps as opposed to if you were doing it manually. That is because we have the SDC DevOps team at SDC has developed the workflow such that it's a fairly automated process. There's a very few manual things you need to do, and the automation process is ongoing. In fact, when you people join SDC DevOps, you will be working in the same team as us, and you will be working to further automate the work of SDC. So basically, what we handle as DevOps intern at SDC, networking, security, deployment, integration, monitoring. Let's discuss, so example, integration. So an app does not simply have a home page, a front end. It has a back end, it has a database, it might have a queuing system, lots of different things. Apps can have an AIML backend that is separate from the original backend, whatnot. How these are connected together, how the app behaves in front of the user, how it is proxied to a domain, how the how the app maintains. So the app should, so for example, you guys upload your NPTEL certificate or something. So that is a project that SDCMujCSE that SDCMujCSE developers develop, and DevOps handles the deployment of that. So when you upload uh, NPTEL certificate and it is validated and you're given marks for it, that's the effort of both the software developer and the DevOps team. So the software developers made the software to win. The DevOps team ensures that your certificates are processed in a proper, secure, uh, encrypted manner that you know like do not compromise your privacy. Make sure the certificates are actually valid. We do not want people who did not appear the exam to also get the certificates. All that is validated by both these teams. And the mantra of DevOps overall, if I had to give you one word, it would be automation. DevOps want the computer to not be in the way of anybody. We deal with the computer so that other people don't have to. So if I want to put a website, that should be automated. If there's a change to the website, I want that change to happen quickly and without any downtime. So I don't want an end user finding out that my website had a change. Like I want them to see the change, of course, but I don't want them to know that I had to, take down the website to do it or anything like that. If any hiccup should be there, they should be minimized. We want to minimize downtime. Any computer service we are managing, we want it up for as much time as possible. Okay, that's our goal is 100%, and we can realistically get very close to it. Like right now, if we open the SDC status page right now, I'll put up a screenshot of it. You can see that our team has ensured 100% uptime of all the projects of SDC. I'll put it in the chat, and you guys can see for yourself. Okay, and when these two services do go down sometimes for various reasons, there might be an outage on the server somewhere, our server might go down, whatever, and that's the team of the DevOps team to handle. We have notifications, so we set up notifications and we know when something like this goes down. Okay, so I think that concludes SDC's DevOps. We'll have a more in-depth workflow discussion, but I think that's it for the basics. Mm, yeah, that's it for the first part of the bootcamp. Now we'll discuss the next part. Karan, can you take over? And for if anybody has
Yeah,
any
sure.
questions, they can put them in the chat and I'll be answering them.
Okay, so no questions, I'm assuming. Okay, then we'll move on to the next part, which is getting GitHub. Yes, sir.
Just 1 minute before. So I hope all of you are going along what Arnav has already spoken. I hope you understood very well. And also you can, if you have any question, you can put down in the chat. So these things are extremely important and critical for your understanding. And if you doing as they are doing hands-on, you are trying like while they are instructing, you are trying along with your laptop. Definitely, you will be in upper hand while you join your organization. You will all be equipped with all the knowledge there. One more thing is there. I will be forwarding a feedback form at the end of the current session. So there will be a feedback form plus your attendance. So based on those things, we will be calling for your interview and all those things. And also Karan will be providing some task for you. So that also will be an added part of extra layer of your evaluation purpose. So take these things, this feedback form, and then the task which Karan giving is important for your understanding. Yeah, thank you. Any question you can put down in the chat box. Thank you.
All right, so let's start with Git and GitHub. How many of you have already heard about this and Git and GitHub? You can just raise your hands, or if you have a very rough description or anything, you can write it in the chat as well. Or better, just open your mic and speak for yourself. Okay. Just one. Okay. Yeah. So anyone would like to pitch in and write a definition, or what do you understand from Git and GitHub? Okay, so I'll be waiting for the comments like while you write the messages. Till then, what we can understand, like let's start with Git first, and then we'll gradually move on to version control tool. Absolutely. So as we write software, we also need it to be maintainable. So we write it in the way like we can control the versions of it. If I write one line of code today, okay, let's actually visualize it. That would be better. I'll share my screen 1 second. Okay, I hope the screen is visible to everyone. Okay, cool. So I'll write, I'm sure everyone would be comfortable with Python. Okay. So this is a new file. I'll try like starting of scratch. I'll write, let's say, print hello world. Okay. This is the first line of code that I've wrote right now. And let's say I push it to Git. Okay. Let's start from scratch again. This is the first line of code that I've written right now. And if any other developer were to write print, let's say, hello, Karan. So we just need to keep track of like who added what line. And just in case if we were to go back, let's say this line has some fault, let's say it did not have this bracket and the code did not run fine, then we can revert to the previous version, which is just this line. So version control system enables us to do just that. So get, all right. I'll also go to a whiteboard. Okay. We can visualize it in a way. Let's say this is my main.py. And I've written just one line, which is print hello world. Okay, this is one line. I'll call it the first line. And then let's say some other developer joins in and write hello Karan. And let's say without the closing quote. This line has some issue, right? And my code stops working right now. So what I can do is if I am using Git, I'm tracking the versions. I can go back to the previous version and see like the code runs still here. And now I know exactly what is the issue. The issue is with the second change. So Git allows us to do just that. So I'm sure we must be very comfortable with like what version control is. We'll also get a hands-on like how we do it. We can understand it as checkpoints. So let's say this is the first checkpoint I added. 1 second. Yeah, this is the first checkpoint I added my first line. And then we can also add another checkpoint, which is for the second line. And we'll talk it a bit more in detail about what these checkpoints are, how to visualize it, and all of that. So I'll open up my terminal. Okay. Now let's say this is the first line. I'll initialize a Git repository. Now, what does a Git repository mean? When I have this single file, I just have one line written. It's not being tracked. It's like any other file on your system. I'll have to write one more thing, Git. So everyone needs to install this software first. You can just look online, it's gitscm.com. I'll also drop it in the chat somewhere. Yeah, Git is a version control service, and GitHub is a Microsoft platform for remote management of the project. Absolutely, Shaj. Now, what you can do is go here. You can download it for your operating system. There's Mac, Windows, Linux, there's everything. You can just download and install it. It's just next install. So yeah, once you install it, then I think we can follow along. Okay, so the first step is initializing a Git repository, which means a folder that is capable of tracking these changes. So to initialize it, we just do git init. And now it says I've initialized an empty Git repository in this folder, which is basically SDC. Now, if you look closely, there's a hidden folder here, which we have already learned the list command, that is ls. And if you write ls space -al, it would also show you the hidden files, which is .git. If I just do ls, it would not show hidden files by default. It just shows main.py. And when I do ls-al, it would also show me a hidden file, which is git. Okay, so maybe we can just go inside it and check what is inside this hidden folder. We won't be like changing anything here because this is something that is automatically maintained. As we write down commands, go with it. So just for your understanding, where are all these changes tracked? It's inside this .git folder that we have. It's obviously hidden and would not show up here in the file tree. Okay. Now I can do something like git status that would show me whatever file set that I have. So it's just main.py for now, and it says untracked files because I have not added it into the version control system yet. So what's the command for that? Let's keep it simple for now. It's just one line of code. I'll do git add main.py. With the git add command now, I have added this to my version control system. I'll also open this. So there's a lot of areas that we'll talk about. This is the staging area. Staging area is where I've tracked the changes, but not have committed yet. We'll also talk about commits in a bit. I can also do git status again. And now you look at the difference. When we did git status previously, it showed up in red and untracked files because we did not track it yet. We tracked it with git add main.py. And now we do git status. It says changes to be committed, which means the file is now tracked. Now, as you see here in the state changes, we have the main.py and also the change that we have done, which is add file. If you also want to check, you can also do git diff. Git diff would basically show you the changes that you have not added till now. We have none because this was the only change that we have added. Now we can try adding another change. Okay, let's say name equals Karan. Okay, I've saved the file. So whenever you do git def or any other command that opens full screen, you can just press Q to like close that terminal session. So I'll go git def again. And now this would show this a one line or a two lines difference actually. I've added two more lines. And Git VS Code also has this visual representation of the lines that I've added. So it shows me I've added two more lines. And these are the lines that have not been added right now, that has not been staged. So it also shows state changes main.py and changes which are pending that are not staged. That is because these two lines have not pushed to staging area. Okay. Now I can do git status again. I have the changes which are staged. That also I can check with git diff staged. Def is meaning basically for difference. And it's two flags. So when I do git diff staged, it will show me the changes that I've added. That is print hello world. And the changes that I've not added in the version control system yet, that would be just git diff. Okay, I'll again add the main.py changes. And now if I do git diff, it shows nothing because all the changes are added. I can view them in git diff staged. So all these changes are added. Now what we do is I have them here in the staged area. Now I can commit these changes. So these are the changes that I've added. Once I commit this, I basically lock the staging area. By now we can add the files in staging area, remove them. That is no problem. But once we commit them, we basically lock them behind a hash. Okay, I'll show you. Git commit, and then we also have to give it a friendly user message, whatever we are committing. For me, it would be, let's say, add main.py. That would be my commit message. Now, once I commit, the staging area is empty again. And if I do git status now, it says on branch master, we'll talk more about branches. Nothing to commit, clean working tree. So the working tree is what I'm working on right now. Once I add the changes, it goes to staging. And then once I commit them, it goes to commit. So you can understand them as three like levels of each other. So one second. Okay. This is my working area where you write your code. Okay. And then this would be your staging area. For pushing the changes from working area to staging area, you just do add the arrow here. Yeah. Git add and your file name. Okay. Once you add your file name, you're to the staging area. And then again, just copy and paste. And these are your commits. And how do you get to your commits? You write git commit m. Git commit -m and your commit message here. Okay. So again, just to recap, you make your files, you keep writing your code, then you add them. This means you have tracked them in your version control system. And once you write git commit -m, whatever commit message you have, basically defining the changes that you have done to the your code, you can pass it to the commits, and now it's in the commit history. Now, how can we view the changes that we have written? Of course, you have your file tree. You can look at here. This is the file that you have, but you can also do something like git log. Now, git log, this shows my previous commit. It has a commit hash, which is a unique identifier for this particular commit. It has the author name, which is mine, and email ID, which is associated with your account. We'll also look how to set this. How is it getting this information from? Also, the date and time when was this committed, the time zone, and the commit message basically. Again, I'll just press Q to close the screen. Okay. Are we clear till here? If you have any doubts, you can write it in the chat or raise your hand. Abhi tak we've just done git, understood what version control system is, how files are added to the version control systems, how we commit. We'll also visualize it a bit more like in depth to see how commits stack on top of each other and all of that. No doubts? Okay, I'm assuming we're good to go. Yes, so far, all the commits that I've done, that is just one, add main.py, they're locally stored. Once we understand how version control works, how we can add these files, commit these changes, we'll also push it to GitHub and understand what GitHub is and the difference between Git and GitHub. So right now we have not touched GitHub at all. This is just Git, the CLI tool Git. Also, once you install, you can just type in Git, just Git, and you can verify if it throws some error, then you do not have it installed. Otherwise, you'll see a lot of information how you can use it. Okay, I'll keep checking the chat section. You can drop your questions in the meanwhile. Okay, now we have added one file, we have one commit. Now let's say I were to make more changes. Let's write a function which is, okay, I'll also write my last name. Last name equals, and let's write a function which prints full name. It will take first name, last name, and return name plus last name. Yeah. Okay. So I've done these changes now. Again, how do I view what are the changes since the last commits? It's just git diff. Yep. These are the changes that I've added. If I were to commit it, I'll first add them to staging area. Yeah. So it's in the working area right now. I'll add it to the staging area by git add file name. So the file name is git add, okay, yeah, git add main.py. Now we are in the staging area. All our changes, it shows up here in the staged area. Now we have to commit it with git commit -m and the commit message. Git commit -m, and the commit message would be add a full name function, or add a function to return full name. Yeah. Enter, and now it has been committed, and you won't show you won't see the staging area right now. And it also maintains this is an extension for Git. I'm not sure if you'll have it by default. You can install it from the extension. This is just again for visualizing. Now we see I have add main.py and another commit, which is add a function to return that I've just wrote. Now if I check git log, we have both the commits. Now how these commits stack on top of each other. So this is the commits area. I have two commits, which is this and here. So my initial commit was add main.py and this add main.py, and this is my second. So this is how it stacks up on top of each other. I'm working. I pushed it to staging with git add command. Once I commit it, it gets pushed. If I commit a new change here, it would go below this. So yeah, it would be somewhere here, right? Yeah, it would just go below this. And these commits keep pushing like each other on top. It's like a linked list. We'll understand how it works. So as we see here, okay, these are the two lines that I've added. This is the first commit, which is connected to the second. And then similarly, we have, you can understand these dots as commits that we have committed. And similarly, these are linked on top of each other like this. Each box or each commit has its unique identifier, which is a commit hash, and we can refer to them with this hash. Now, one more thing, I got a bit of ahead of myself. Git config. Okay, yeah. So this is a command for setting up your identity, because when I do git log right now, it knows who I am, what my email is. So once you install your git git CLI tool, you have to run these commands. This is for email, git config global user.email. And there's one more similar to this, which is git config, yeah, global user.name. Okay. Yeah, here I can pass on my name. And this is how you set your identity. If you just want to verify what you have set, git config global user.email, it would output your email, and the same goes for name. So you can verify it like this. So when you're committing any changes, it would be with your this information that you have added. Okay. Any changes till here? So any doubts till here? All right. Now, what are the benefits of this? Let's say I add one more change, def, return, okay. Let's say last name, and this just takes last name and returns it as it is. Add, return last name, yeah, and returns it as it is. Okay. And if let's say I make a change here, I'll make it 1. So this will break my code. Okay. Now I'll add it intentionally. I'll clear my screen, get status. It's in the working area. I add it. Okay, now if you are working with multiple files, if you have a big project, a git add file name might be a bit more taxing when you're adding multiple files in the same commit or in the staging area. So you can do git add dot, which would basically add everything that is in your working directory and has been modified. So you can do git status. It would show all the files that you have. You can do git add dot. It would automatically add all of them to the staging area. And then you can also check git status again. My changes have been added. And now I can commit them. Let commit, let's say add error. Okay. So now we have three commits, add main.py, add a function to return full name, and add error. Now I can do git log. There's one more feature that Git has, which is very cool. Okay. Which is git blame. So when you're writing code, every line has someone to blame, basically whosoever wrote that file. Now you can run git blame and then whatever file you want to run it on. And now it would show me exactly who did what changes and when. So since I've committed all of these changes with my account, it would show Karan Parashar everywhere. But you can see the time difference. So the first line was added somewhere here, okay, 4:13. And then the next lines were added at 14:18, which is 2:18. And likewise, yeah, 2:22, all of that. So you can also look at the changes who added what line with git blame. I'm sure there's a VS Code extension for that as well that shows it to you visually inside the editor itself. So these are just good to know commands. You won't be using all of them in practicality. These are useful when you're working inside the terminal only and you do not have access to a code editor, let's say VS Code. Okay, now we have added a faulty file, like 42 lines of code, which breaks our code. Now, what makes version control so powerful is I can revert this change, not manually. I do not know what change has been added with these lines. So what I can do just do is git log. Okay, first I'll do git blame. Okay, git blame main.py. I'll check these are the changes that I want to remove. I'll copy the hash, which is the unique identifier. This is just the shortened version of what we saw in the git log. I'll just copy it. I'll run git revert, and then I'll paste this. Okay. Now it says revert add error. It just opened my terminal or text editor. We'll look at it later. For you, it might be nano by default. So this like procedure for saving and closing it is the same, which is Control X and then Y to confirm. Now we have one more commit, which is revert add error. We have reverted the change and the lines have disappeared for us. And now our code again is good and is ready to be executed. So this is how we can add the changes. We can also revert certain commit messages. If we look at git log again, we can see this is the commit message, the SHA that we reverted, commit hash, and it matches this. So this is a new commit with a new commit hash, which is revert add error, and this reverts the commit, the previous one, this one. Also, if you want to, if you have a lot of commits, you can do a git log one line. How do you get graph tab in VS Code? Okay, this is for me. I did not install any extensions, but I'm sure it's Git. Mm, okay, I'll look at it and confirm it later on, but I did not install any extensions. This were inbuilt for me. Maybe it's hidden for you like this. You can just expand it. It's
Yeah, the graph tab is
just a
there by
history.
default.
Yeah, all right. So you can do git log one line and you'll get all the commit messages without the descriptions and just the commit titles and also your branch. Now let's understand what this head is. So let's take this example only. Okay, if I can select this. Okay. Now these are our these all are our commits that we have done. So four of them. Now we are on top of these, which is my head is at revert error. Okay, perfect. We have four commits. My head is at the top right now here. I've drawn these arrows wrong. It should actually be pointing upwards. So I first made the initial commit here, then made the second commit, and then third, and then fourth. Okay. Now this, okay, second. this is where my head points at right now. If you have learned about linked lists, then you'll understand this better. But yeah, my head is pointing at this right now. So if I were to go back to the previous message, either I can reset my head to the previous commit, or as I did, I reverted it. So my files are back to this changes, which is back to these lines, just these lines. In the third commit, I added two more lines, and in the fourth commit, I deleted it. So essentially, these two cancel out their changes and do nothing. So there's two ways of like deleting the changes from commit history. One was I reverted it, and the other would be resetting my head back to the second commit, which would also get me just this and remove the extra lines that I've added. Let's look at how that works. Again, now I have two commits. I can do git reset hard. Hard meaning also the changes that the commits have done. I'm also resetting them. And then I can mention here head by what number. So if I just want to reset head by one, then I'll basically be pointing at here where I still have the faulty changes. Okay, let's run this. Okay, I'm back to where I had the change and also had this faulty change, which is the last name wala change. And now I have three commits. I've essentially lost this commit now. And if I go back one more down the line, then I can again do git reset hard, head one. And now even I've removed that commit as well. So my head is pointing at here. So head is basically your present state of code, your current state of code, what you're pointing at. So I only have two commits and my head is pointing at the second commit. So I hope this is clear. Again, if you have any doubts, you can literally raise your hand in the between or leave it in the chat section. I look at it. Now let's understand how do I push these changes to GitHub. So as we talked about a repository, we did repo init for initializing a repository. This, all the changes that I've done so far, all these commits that I've done so far that you see here, these are all locally stored on my laptop. Now, the first step would be you create a GitHub account, and GitHub is something where you can push these changes. So all the changes that I have, the repository that I have stored locally, you can store it on GitHub. And it also gives you a very nice visual representation on how you can look at your commits, commit history, and all of that. Okay, we'll see that now. Okay, so I'll open github.com. So you might have to create an account if you don't have one already. I'll click on the plus button. I'll create a new repository. Okay, once I have a new repository, I'll choose the owner as myself. Let's make this SDC test, and I'll make it private for now, or also public, so you can see I'll call it workshop. I'll leave the link for this repository in the comments so you can also look and visualize the changes. Now, you do not have to change anything else for now. There's the commit description optional, the visibility if only you can see the repository or anyone on the internet can. There's a few templates, readmes, we'll just skip that for now and click create repository. Now, this is a fresh repository. And now let's understand the difference between remote and local. So all the changes that I have done right now, all these commits that I have, these are local to my computer. And once you push it to GitHub, push is the correct word for uploading these changes. So once I push it here, it's on the remote. So now we are playing with two remotes. One is local and one is remote as in GitHub itself. So it also gives you instructions on how you can create a new repository on the command line and then push it. Or if you have an existing repository, you can push it from the command line. So in our case, we already have created one, which is with git init. We did not have readme, we just had main.py. It also has the same syntax, which is git commit -m first commit. Branch, it's by default master. And now we just have to run these two commands. So we'll essentially be looking at the second one or push an existing repository that we have created locally from the command line. So git remote add origin. We'll copy paste it as it is. And then git branch m and git push. Okay, now I've pushed these changes inside this repo. If I refresh, it should show up. All right. Now I have this main.py file pushed with all the changes that I had done. And if you remember, I reset the top two changes with the reset command, git reset hard. So I only have two commits. Now, this is how the interface looks once you push it on GitHub, which is public repository. I'll drop the link in the comments if you want to also have a look at it. Now, if I look at the commits, it has a really nice UI. You can also look at one of these commits and check what the changes were added. It added these 3 lines. And then the second commit, what did it added? It added a few more lines. So you can understand these checkpoints, like these commits as checkpoints. So basically, assume you're playing a game, you have completed the first checkpoint, and then second checkpoint, like how they stack up on top of each other, and then you have the next checkpoint and so on. So you can understand commits like that. And this is the commit ka unique identifier that we talked about, the SHA. You can copy the full SHA with this copy button. And here we have branches. Any doubts so far? Okay, so one thing that I've missed is I've authenticated with my GitHub account, and that is how it knows how I've pushed these changes. For you, if you're pushing it for the first time, it will ask you for authentication if you're the owner of this repository and you have to authenticate it in some way. So the easiest way is you can go to your settings or scroll down to developer settings and personal access tokens. You can go to tokens and then you can create a new token. And then for now, just use a classic token for general use. And it will ask you to basically authenticate with your GitHub account again. And now you can add a SDC Bootcamp. Just the name for your key does not mean anything. Expiration, how long it should last. Give it rights. I would recommend you give it only the repo one. I think that is sufficient for pushing. Okay, all right. Now I'll do generate token. Now it gave me this token that I can use for pushing. I have SSH authentication set up right now, but until then you can use a token, and this is confidential. Treat it like your password, do not share it. I'll delete it for now, but you get the idea how you can push. So when you do git push again, like for the first time, it will ask you for password, and that's where you have to enter this token. All right. So we have a few changes pushed. And yep, so GitHub is basically where you can push your repositories, upload your repositories, and can basically collaborate with people. So this repository can be cloned by someone like one of you. You can also commit these changes and push it to my repository if you have the permissions to. In the settings tab, you can also add collaborators here, and they can also have the permission to push it then. So that's basically how you use Git. And with using Git version control system, track your changes, add your changes, commit them, and then push them to GitHub. Any doubts so far? Okay, the token part again. All right. So let's do one thing. I'll generate a token. I'll also show you how you can push it. So let's say you have created your GitHub account just now. I'll go to settings. In settings, just scroll down to developer settings. It's on the left, bottom left. Go to personal access tokens. You can, for now, I'll be using a fine grained token. Generate new token. Token name SDC Bootcamp. You can give it anything. You can also give it a description, an expiration date, and you can also select what all permissions does it have. So I'll select SDC for now, SDC workshop, and generate token. Yep, generate token. I'll get this one-time use, not one-time use. This is a token that is valid for 1 week. You can set the expiration date, and now you can use this as your password. So, okay, it would not ask me the password. What I can do is, hmm, 1 second. Okay, I'll go to one of my servers, KDI test. Okay, it should ask me password here. Okay. So right now I've only generated the token, and now let's see how can we use this token to push changes to our Git. Okay. So first I'll clone the project. So for cloning the project, if you have to clone this project, or let's say a friend of yours, you just have to go to the code button and go to HTTPS. You can copy this URL. I can do git clone and I'll paste the link. So you do not need any permissions for cloning because the repository is already public and anyone can clone it. So cloning is basically, I had this repository on my local system, but if someone else were to do it, if someone else were to download it, then this is the proper way of downloading it, which is git clone. They also had this download zip button. I recommend you not use it for now because yeah, I'll like go in depth in a bit. Like why should you not use this if you're contributing to a project? Okay, so HTTPS, you just copy the link. Did I accidentally click the button? All right. I just did git clone. By default, it says cloning into SDC workshop. If I do ls again, I have the folder. I'll go into the folder with cd command. Okay, now if I do ls again, I have the file. And I'll also see cat main.py as Arnav explained. It will show me the contents of the file. Now let's edit this. Since I'm in a terminal-only interface, I'll use nano text editor to edit the file. So it's nano main.py, and we'll go to the bottom of it. And let's add one more line. Let's call this function. So print full name. I'll pass in name and my last name, and this should print. Okay. Now for saving file, I'll do Control X. Save modified buffer, yes. So I'll press Y, and then file name to write, which is main.py. Okay, enter, confirm. Now I've made one change. I'll do git diff just to verify. Yes, this is the changes that I've done. Now I'm in my working area. I'll push it to staging. So git add main.py. Now if I do git diff again, that's empty. Now if I do git diff staged, it should show the difference in my staging area, which is fine. Now I'll do git commit and call the function. Enter. And now if I try to git push, it will ask me for my username. I'll put my GitHub username. And then it's asking me for password. So here you are not supposed to use your GitHub password. Even if you use, it will throw up an error. So what I'll use is the token that I've just generated. I'll copy the token. I'll paste it here and enter. Denied. Okay. Is it Karan? I might have not given the key. Okay, let's generate a new token. Let's go to fine grained again. For you, it should be a classic token. Generate a token, SDC Bootcamp, resource owner, expiration date, only select repositories, SDC workshop. And now here's the repository permissions. So contents of the repositories, it should be read and write access. Yep, I don't think I need anything else. I'll generate token. Yep, it should work now. So if I do git push again, and with the token, it has pushed the changes to my GitHub repository. So if I go back here, I'll refresh the page. The changes are committed. Okay. So one more thing here, the git config, if I show you git config global user.name, it's set to someone else's name, right? And that is why it showed up as a different person when I committed it. So on your system, ideally, it would be yours, so you won't face this issue. But as you see, here's the third message that I pushed from the server using the token. I think that explains it. And also, if you look at the file, as I showed you the git blame thing, they also have a GUI for it. So you can exactly see which lines were added when and in which commit. Okay. Any questions so far? All right. I'll still keep an eye on the chat box. You can write your messages there if you have any. Now we have completed what is Git, what is VCS, what is GitHub. You know the difference between the two. Git is just a CLI tool that you can use to version control your system. And when you are to upload your repository to GitHub, that is where GitHub is used. It's just a hosting platform like your Google Drive, but instead of taking regular files and folders, it only accepts GitHub repositories. So that is GitHub. We have learned how to set up a GitHub configuration with this GitHub config -- global command. There's also a cheat sheet. GitHub has a GitHub Git cheat sheet. That's the first link. I'll also send it in the chat. Yep. Okay. So let's look at this. So installation steps that we've already covered. Setup, you have all the commands here. That is username. You can put your full name here. You have the email. And this is something that you can do for colors. So when we do git status, or let's add a new file, let's say new.py, where to git status now, it shows colors. So you can also play around with these colors and have them differently. That is this command. And then you have git init. So this is the first command that you run when you are supposed to initialize a new repository. So this is when you're initializing a new repository on your local laptop. If you already have a repository, let's say the one that we have here, then you use the git clone command. That is git clone and the URL. Let's see what they have next. That is git status. Show the modified files in the working directory that we talked about. And then we have git add the files to your version control system. It does not commit it yet. It just adds them to the staging area. And then whatever you have in the staging area that you can commit with git commit. So when you run git commit, it adds all the files that you already have it in your staging area, and then you have to write a descriptive message for it. We'll also go a bit in detail on how these messages should be written. Like there's some good practices on how you should write these messages. Now git reset, as we talked about, this is your head. It usually points on the top. If you have 4 commits, it would be pointing on the top, the latest one. If you were to reset, you can reset it to any of them, and that's where you'll go. So it's basically for going in behind in time and past. So we have git reset, we have git diff for viewing the changes that are in a working directory, git diff staged that are for changes in the staging directory, and git commit. Okay. All right, now let's move on to branches and merge. We'll also do a pull request example. All right. So what are git branches? Okay. I'll exit from server, go back to local. Okay. Now, if I run git branch, it would show me I'm on the branch master, which is the default naming convention. If you create a new repository, you'll be having the default branches mastered. Now, what are branches meant for? I can switch to a different branch. All right, let's first see what is the use case. So if, let's say, I were working on some feature and Arnav is working on some other, this is the base code that we have. We both are independently working on different features. And so we have a different copy of this repository locally stored. So what we do is we create different branches and we work on basically our own branches. We work on the feature set, and then we can merge our branches into the main one. This might not make sense right now. We'll just see it in action. So git switch C to a new branch. I'll call it feature branch. Now I've switched to a new branch, which is feature. If I do git branch now, I want the feature branch that is currently set as active. Again, whenever this full screen opens, I can just press Q and that should close it. Now let's work on this branch. So, okay, what should I do next? Okay, let's write another function that should return greet user, greet user, name. It takes your name and then it return string hello and then name. All right. So let's say if I was working on this feature, I wrote the code for it. I saved the changes. I'll commit it quickly. Git commit add a function to greet user. I've committed this, and now I'll push it to a separate branch, which is um, yeah, which is feature branch. I'll do git push u origin, and I'll change the branch name from master to feature. Okay. Now I've pushed a feature branch, which is different. So I have two branches now, master and feature. They can have unrelated commit histories. They can have unrelated files. That is all right. So I'll go here. I have a greet user function. Even if I were to check the commit history, we have two commits and one more, which is, yeah, this one that I just added. Now, let's say if I were to merge this code onto my main branch, or the master branch that we have. I worked on a feature. Now I feel that feature is ready. Now there's something called as a pull request. That is what I'll create. So when you're contributing to an upstream branch is basically the main branch that everyone is working on. And then this is a branch which is, you can call it a side branch, or I've sidetracked and added a feature, and now I'll push it back to the main branch. So I'll go to feature, I'll do compare and pull request. I need to add a title and describe my changes if possible. What this changes does, it will show you this is the commit that I'm going to make pull request with. These are the changes, and I want to merge this into the main branch. So base branch is master, compare branch is feature, and I'm pushing the changes as you see the arrow from feature branch to main branch. I'll create a pull request. Okay, my pull request is now open. So I'll go to pull request again in the same repository, open the pull request. I can see the changes. These are the changes that have been done. The commits that I want to merge. Yep. So, okay, now we have conflicts as well. Okay, this is the perfect time to also learn about what are conflicts. We'll understand why this happened first. Okay. So my main.py file has this line, which is print full name, and my feature branch does not have it. So it's basically a conflict. I'm trying to add these lines, and it does not. If I add these two lines, it also sees there are different unrelated lines below, which it did not expect it to be there because the feature branch does not have these lines. So this is a conflict, and this is something which you'll like very often see if you're collaborating in projects. Okay, so let's go to resolve conflicts. Okay, now, okay, this is important and a bit advanced. It's fine if you don't understand it right now, but we'll just try to look at it. Now, these are called as conflict markers. All these arrows that we have, the equals to sign, and again, the greater than sign. And now what these mean is, if you see there's two sections, the first section is here, and the section is here. Now, if I'm merging this branch, these are the changes that should exist, and these are the changes that are being added, like that were not expected. So the first block always shows the changes that I'm trying to add right now. And these are the changes that were there previously, but it's on me whether I want to add it or not. So either I can remove this thing entirely. So after merging, that line won't be there. But since I want the previous changes as well, I'll just remove the conflict markers. First, I want my changes, the ones that I added just now. And then I also want to keep the latest change. Now I've removed the conflict markers. I can mark it as resolved. And now I can merge my commit. Okay, this shows open, that should be merged now. Okay, I've resolved the conflict and I'll now merge the pull request. Confirm merge. Now if I go to the master branch, I see 2 more commits now. My function to greet the user has been added. There's a merge commit, which you'll always see. This is typically the conflict resolution. And then the commit which shows whatever changes have been done. So these are the changes that have been added. And this is how we merge a pull request. So as a task for you guys, I'll create a new repository under the SDC account. And what you're supposed to do is you're supposed to fork it. Okay, we did not talk about forking. Let's go to, so I'll create a new repository here. SDC Bootcamp, make it public, initialize it with a README. Okay, so what I want you to do is I want you to fork this repository. Forking it is creating a copy of it on your personal account. Currently, it lives on SDC's account. What you're supposed to do is I'll show it to you. I'll fork it under my account. I'll create fork. Takes a few seconds. I'll clone it. Again, the same procedure. I'll copy the HTTPS and go back to my terminal. Okay, I have it open here. One second. Yeah. Yeah. I'll do git clone, paste the URL that I just copied. I'll go to this folder, SDC Bootcamp. Now, if I do git log again, I have just one commit. That is the initial commit. I initialize the commit with a README. That is there. Now, let's do a commit. I'll do nano main.py. Again, I'll just do print hello world. I'll save this, git diff. Okay, git status. This is untracked file, so this won't show in git diff as long as it's not tracked. So we'll track it first, add main.py. Now if I do git diff staged, it's in the staging area. Now I can commit it. My bad. Git commit -m add main.py, and now I can push it. So I've cloned the repo, I've made some changes, I've pushed it, and it should reflect on my fork. It says SDC Bootcamp forked from SDCMujCSE Bootcamp. I have a commit and it's there on my fork. I do not have permission to directly push on the main repository, which is, okay. Yeah, this is the main repository. It still has one commit. I've created a fork with the fork button. It's now on my profile. Once I've forked it, I've cloned it locally. I've made some changes. I've committed them and pushed them. So it should show up here. And now what I'll do is I want to contribute this change to the original repository. So how do we do that? I do contribute again, open a pull request. And by the way, this would be your assignment after this workshop. All of you have to go to this repository, create your GitHub accounts if you do not have them already. Fork this repository with the fork button. Once it shows up on your profile, just go to code, use the git clone command to clone it, do some changes, whatever you feel like, as long as they're not like, just do some changes, commit them, and then come back to your profile, come back to the repository. You'll have this button to contribute, which says your branch is one commit ahead of the original repository. You'll go to open pull request. Now it says base repository is SDCMUJ/SDC Bootcamp, and the head repository that I'm making the pull request from is mine. Now I'll add main.py commit title and a description. This is optional. And I'll go make a pull request. Okay. Okay. Now I made a pull request. This pull request should show up here in the pull request page of the SDC repository. Now, pull request is basically the go-to way if you want to contribute to any GitHub repository. We'll look at an example as Arnav talked about Linux, the Linux repository. We'll go to this pull repository and we see they have 474 pull requests pending. So, okay, we'll open one of them and see what they're going on, like what they're doing. This is the commit message that we have. This is the pull request number. They have 1275 pull requests. This is the commit description, basically describing the changes that you do. And if you scroll down, people can also comment and review your changes that you have done. You can go to files changed, look at the changes that people have done, go to conversation. And once you make a pull request, the repository owners are supposed to review your pull request. That is someone, it's an automatic one, I think. A bot has left a commit. Thank you for your contribution. And basically the review that they have. So you can also discuss the changes that you have done with the maintainer here itself. And when they find the changes good or good enough to be merged, what they can do is go to the pull request. Someone with a permission should have this button, merge pull request, and I'll do confirm merge. And now I should have the changes in the SDC repository as well. So this is how we contribute. So you fork the repository, you make changes to your fork, you push your fork again to your profile only. Where did it go? Yeah. You clone your fork, make the changes, push it back, and then use the contribute button, and then make the pull request. As like whenever any reviewer sees your request, they can review it, ask you for further changes, or if the changes are good enough, they can merge it directly. Now, what your assignment would be after this meeting is to fork this repository, make changes, and make pull requests. Any doubt till now? Okay, I assume none, but I'll also keep an eye on the chat section. Now, I know we are hitting the time limit. All right. I know we are hitting the time limit, but we'll try to like quickly cover one or two other things that we have. Now, oftentimes we have something called as environment variables or secrets. Let's say if I have my API key or any secret here, I do not want to push this on GitHub. These are a few good practices that you should know. Let's say I have some API key over here. I do not want, this is like a secret or passwords that you might use in an applications, and you do not want to push them to GitHub. So that's where another feature comes in, that is git ignore. So this is a special file. Okay, I'll zoom in a bit. This is a special file that GitHub recognizes, and you can just write the name of the files that you want to ignore. If I do git status now, I see it says untracked files.env, but I never want to track it. And if accidentally I do git add dot, it would track the file. So what I'll do is I'll make a git ignore. I'll add the env file here, just the name or path of the file. So once I do git status now, it does not show me the env file anymore. And if you look at the file color as well, it's a bit faded right now because it will never be tracked. That's in the git ignore. And git ignore is something that you can commit because it just has your file name or file path that is safe to commit. So that is git ignore. You should ignore all your passwords or anything if you have these environment files. It could be a different name, or let's say your code settings. Oftentimes you get a .vs code folder if you're working with big projects. So you might also want to add it in git ignore, and yeah, like that. Now let's look at what are the best practices for writing these commit messages. I've I've not seen many people talk about this, but your commit messages should be written in present tense. So if you see all the changes that I have pushed till now, let's look at STC workshop. Yep. All the changes or all the commits that I've written till now, it's in the present tense. Add a function, add main.py, call the function. That should be very simple to read and also self-explanatory on what your changes, like what changes does it have. So add a function to greet the user. If I do not even open this commit, I kind of am expecting there would be a function which basically returns hello or something. So make them as descriptive as possible and also keep them short enough so they can fit in this UI space. Maybe a few more words, that is fine. And then there's commit description. So I've not written descriptions for any of them, but if you see here, it has a commit description. So commit description, you can write it in the past tense, and you can basically mention key you've added this function, or basically explain that why that change was done. So commit message is basically what changes were done, and description is why were they done or why were they required, basically explaining it. So if someone is reviewing your commit history, they can know what changes were done and for what reason. So that are some standard practices. I want, like, when you're creating these pull requests, I want you to also write a commit description. I'll show you how to do that. Let's say I added a git ignore file. I'll add it, git add, git commit. Okay, git commit. This is basically your commit message. And if you do not pass the m-m argument, it would directly open this in your text editor. And now here, it would open some screen like this. And yours might not look the same, but here you can write your commit message. It would basically open up Nano or VI text editor for you, depending upon your operating system. So here I'll write add.getIgnore. And now I can describe my changes here. Added git ignore file to prevent secrets from being pushed. And now I save this. For you, it would be again be Control X and Y. And now I can push this. Okay, this is another thing that we can look at. If I do git log, on my local repository, I only have a git function to greet user, and then this is the next commit. While here, after this, I have a few more commits. So it would not let me push because the histories are unrelated. I'm supposed to have all these changes, and then I can push it. So here, what I can do is, since I've already committed something on top, and there should be more things between here, I can do a git pull -- rebase. You can ignore the rebase thing for now, but for pulling the changes from like GitHub or an upstream repository to your local git pull is what you use. So I'll do git pull rebase. It should pull all the changes. If I do git log now, I have all the changes here, the previous commits. We can also visualize it here. Yep, we have all the changes. It also shows the merge branches. So if you see, these are the commits that I made on the main branch. Then this, we made it on a different branch. And then it was also merged into the main branch. And right now we stand here where we already have all these branches. And we're on the top. Our head is pointing at git ignore. I believe I can push it now since we have the same commit history. Okay, it's pushed. Did not refresh, I believe. Okay, I posted to the feature branch. Let's look at the feature branch. Okay, yeah, I have add git ignore, and I have the commit description with it as well. So keep this in past tense, keep this in present tense. That's what the standard is. That's how people do it. And also it's easy to understand. This is what you have done in your commit, and this is why you have done it. Or if anyone wants more like information on why this change was done. So that is basically the commit history. Any doubts till now? And this is also a good practice to, all right, this is also a good practice to never push your environment variables or any secrets, even if your repository is private. It's always to keep them locally stored, and whosoever clones your repository, even if they want this, they can request you separately, or they can have their own API key. Because these are essentially the secrets that you'll have, similar to passwords. All right. Tomorrow, we'll have more sessions on Docker, containerization, and deployment. I think you'll also have your separate sessions on backend, frontend, and basically the web dev stuff. So once you learn all of that, tomorrow we'll try to containerize a web app, frontend, backend, both, and try to deploy it on cloud. So it would basically be if you write a web app or something, you can basically end to end learn how to put it on the internet. We'll end the session here, and I've left the okay, I'll also leave the cheat sheet there because it has all the commands that we referred to today. Amit sir also left a feedback form. It's in the comments only. It's in the chat section only. You also have to fill that, and also if there's any feedback for me, because this is first time me taking an online session. So if there's any feedback, that would be very welcome.
Okay. Karan, is this all from your side?
Yes, sir.
Amit sir, are you there?
Yes, I'm there. I'm there.
So, Amit sir, can you give some conclude statements?
Of course, of course. First of all, I want to thank you, each and everyone who is present at this point of time in this session. And a special thanks to Arnav and Karan. And you did really good. It's marvelous. And really, I am happy you are the part of our team as a student DevOps coordinator.